Good morning. Today we're going to be talking about absolute value equations and solving them. So, absolute value equations are going to be today, day one, and inequalities will be tomorrow. Absolute value is going to be the distance a number is from zero. Since it is a distance, it's always going to be positive. To indicate absolute value, I should get a pen here. To indicate absolute value of -8, you write absolute value of -8. That is true. You're going to write these lines. That's going to indicate absolute value. Right, the absolute value of -8 is -8, since -8 is 8 units to the left of 0 on the number line. That's going to be false. The absolute value of -8 is just 8. Think about the number of steps you go from 0 to -8. Yes, you're going to the left, but you're still taking 8 steps. The absolute value of 8 is 8, since -8 is 8 units away from 0. That would be true then. Then according to the definition of absolute value, if r is equal to 3, absolute value is equal to 3, then r equals 3 and r equals -3. That would be also true. If you think about it, if I put 3 into this equation, absolute value of 3 is equal to 3. That would be 3 equals 3, and that's true. And then if I put -3 into this equation for r, absolute value of -3 is equal to 3. Well, absolute value of -3 is 3, and that's equal to 3. So that would also be true. So let me get this a little bit more. All right. Solving absolute value equations and inequalities. First, you're going to isolate the variable or term inside the absolute value symbols. Then you're going to, so if I have some absolute value and I have x plus 3, but then on the outside I have -3, I have to isolate this absolute value of x plus 3. Okay, so isolate it first. Set the absolute value, and this is going to be in the equation first. Set the absolute value term or expression equal to both the positive answer and the negative answer. We're going to work on this one tomorrow. We'll get to the inequality tomorrow. You're going to isolate the variable in each equation. For an equation, your answer is an OR. So meaning you're either going to have one number or one number. It could be one or the other. And then for an inequality, again, this could be an and or an or. We'll get to that tomorrow. You may get a solution if absolute value is equal to or may get a no solution if an absolute value is set equal to a negative number. And what I mean by that is, forget this for a second. If I have the absolute value of x is going to be equal to -6, can absolute value, any number, be put in here and it become not negative, so positive, and then equal negative? No. So this would be a no solution. Okay? So to solve something that is inside absolute value equal to 3, you're going to solve b is equal to 3 and b is equal to -3. Meaning if this was an actual expression, like down here, to solve this, you're going to do x minus 5 is equal to 6 and x minus 5 is equal to -6. And if we were to check our answer, if I wanted to solve this, I would add 5 to both sides and x equals 11, or add 5, and x is equal to -1. Now, if I put 11 back in here, 11 minus 5, absolute value is equal to 6. Absolute value of 6 is equal to 6. Absolute value of 6 is 6 equals 6. That is true. Now let's put this one back in here. I'll show my work up here. -1, I'm replacing the x right here with negative 1 minus 5 is equal to 6. Negative 1 minus 5. So again, order of operations tells me I have to do what's inside my brackets or grouping symbols first. So that means I have to do what's inside here. So negative 6, absolute value of negative 6 is equal to 6. Absolute value of negative 6 is 6. And that is also true. All right. So x plus 7 is equal to 2h. Solve h plus 7 is equal to 2h. Well, let's just do negative and 2h. One's negative and one's positive. Here, what are the solutions? And then graph and check the solutions. So here you want to isolate your absolute value first. So I want to add 5 to both sides. So the absolute value of n is going to be 3. So n is equal to 3 and n is equal to negative 3. Okay, if I were to graph this to check, so it's either or. So n is 3 or n is negative 3. If I put n in here for negative 3 and for n, negative 3, absolute value would be 3 minus 5 is negative 2. All right. So solve each equation. If there is no solution, write a no solution. Again, you have to get your absolute value by itself first. So I want to get this minus 25 off of there, so I'm going to add 25 to both sides. Then I have the absolute value of y plus 17 equals, that would give me a positive 15. Now I have absolute value by itself on one side, so I'm going to drop the absolute values, and I'm going to set it equal to 15 and negative 15. And then I'm going to solve both of them. So minus 17 on both sides, and just to kind of save time, and I get y equals 2 and y equals a negative 32. So that becomes that. That crosses out. 15 minus 17, oh, that's a negative 2. Good thing I'm checking my numbers. This cancels out. All I have left is y. So in this equation, y can either be negative 2 or y can equal negative 32. Both numbers would work in this equation. All right. I have my absolute value, and then I have a minus 2 on this side of my equal sign, so I need to get rid of my minus 2 by adding 2 to both sides. H over 3 plus 4, absolute value is equal to 7. Here I'm going to set both of them, drop my absolute value, and set both equal to negative 7. So h divided by 3 plus 4 equals 7. H divided by 3 plus 4 equals a negative 7. I'm going to subtract 4 first. So minus 4, I'm running out of room, is h over 3 equals 3. And then multiply both sides by 3. And that would get h is equal to 9. So that would be one of my solutions. H is equal to 9. Or, and then I'll do minus 4. I'm going to erase them over here. Do some work over there. So here, h divided by 3 plus 4 equals a negative 7. I just brought this over here. Okay, so minus 4, h over 3 equals a negative 11. Multiply both sides by 3, and I get h is equal to a negative 33, I believe. Okay, I should take the time to go put those numbers, either 9 or negative 33, back into this equation, but I am running out of time, so I'm going to go on. Here again, you want to get the absolute value by itself. So I need to add 5 to both sides. I have the absolute value left on this side, 3x minus 6. This goes away, equals, and this gets negative 2. Absolute value can never equal negative, so I'm going to stop right there, and it's a no solution. Never can I have an absolute value be equal to a negative. Okay, let's see. Okay. All right, if you are skating with a friend, the friend's distance from you in feet after t seconds is given by d is equal to 80 minus 5t. At what times is she 60 feet from you? So we're going to, distance is going to be 60. So I'm going to set this equal to 80 minus 5t. Okay, so d is representing my distance, so 60 feet. I'm going to set it equal, I'm just going to switch the sides and drop my absolute value just because that's how I like to solve it. So 80 minus 5t equals 60, and 80 minus 5t equals a negative 60. And then I'm going to solve, subtract 80 from both sides. I have 5t equals a negative 20 and divide by a negative 5. T is equal to 4. And then here, subtract 80, negative 5t is equal to a negative 140, divide by negative 5. So t is equal to 14, double 14, you get 28. 5 goes down. So that means 4, she is 60 feet away from you at 4 seconds and 28 seconds. This is her, the equation of the distance from her. Okay, so how many solutions do you expect to get when you solve an absolute value equation? You expect to get 2. There's not. All right, your homework, page 211, 9 through 31, odd. This is going to be day 1.